Hi guys, welcome to my YouTube channel. If you're new, you're welcome, and if you're old, you're super welcome. This video walks through the steps from the taking a one sample t-test, the two-stage variance. But before then, please do well to subscribe to my YouTube channel, turn on the notification bell, hit the like button, and share this video. Thank you. Let's take a look at the question we have on the board. Alright, the question says, the production manager of a beer company is aware that the maximum pH of his beer has to be 3.6. In view of this, he monitors the pH of his production at regular intervals during brewing. Suppose the following pH values of one of his samples selected at random on a particular production line are 3.2, 3.4, 3.7, 3.8, 3.3, 3.4, 3.5, and lastly 3.1, with mean of 3.425 and variance 0.058. Should the process of brewing continue or an adjustment of the machinery be added at 5% level of significance? Alright, the manager actually wants to find out if the process of production should continue or there should be an adjustment of the machinery. We answer this question through various steps, and here we go. Step 1. State the hypothesis. Of course, we have two types of hypothesis. The first one being the null, H naught, right? Of course, what null is saying is that the pH of the beer produced by the brewery is equal to the population mean, that is 3.6, and then we report it. State the alternative hypothesis, which is designated with HA, is not equal to the population mean, right? So we've succeeded in stating both the null and the alternative hypothesis. The null says that the pH of the beer produced by the brewery is 3.6, while the alternative says the pH of the beer produced by the brewery is not 3.6. So we'll move to the next step. Alright, step 2 says state the level of significance. The researcher said at 5% level of significance, right? Of course, 5% simply means 5 over 100, which is 0.05 significant level. So we represent that with alpha equal 0.05, right? Step 3 says calculate T, right? So we have a unique formula for calculating T. It goes towards T equal, of course, the sample mean minus the population mean over standard error of means. Referring back to our picture, we could see that the sample mean here is 3.425. So here we go, have our sample mean to be 3.425 minus the population mean. Population mean is 3.6. So we have 3.6 here over standard error. Variance was given instead of standard error, and of course through variance we could get our standard error. And here we go now. Standard error equal standard deviation over root n, right? So we have, so since standard deviation equals square root of variance, we have square root of course, the value of our variance given is 0.058. So we substitute that now. We have square root of 0.058, right? And of course, the square root of that gives us, okay, looking at the formula for calculating standard error, we did say standard error is standard deviation. We just got value for standard deviation now over root n. So we substitute that. So we say standard error equal standard deviation, which is 0.240. So we have 0.240 divided by root. We did say n value is 8, right? The sample size. Our standard error would be 0.240 divided by root 8 gives. So we succeeded in getting value for standard error. So we substitute that now here. So we have 0.5. So our t, call that t calculated, would be 3.425 minus 3.6 gives divided by 0. T calculated will be calculated, right? So step 4 says determine the degree of freedom. df, because degree of freedom is n minus 1. N simply stands for the sample size. The sample size, how many are there? We say 1, 2, 3, 4, 5, 6, 7, 8. So n is 8, right? Equal 8 minus 1. So our degree of freedom is 7. df equals 7, right? The next step says check the critical t. Of course, that takes us to our t distribution table. Alright, this is our t distribution table. We'll see the p. P simply refers to the probability level or significant level. And of course, we're talking about 0.05 significant level. And since we're considering two-tailed test, right? So we are looking at 0.05 two-tailed. These are our two-tailed. We trace 0.05 and then degree of freedom 7, right? We trace it down to 7 and that gives us 2.365. This step says accept or reject hypothesis. So accepting or rejecting hypothesis only depends on t calculated and t tabulated. So the rule is if t calculated is greater than t tabulated, you reject null and accept the alternative hypothesis. But in this case, t tabulated is greater than t calculated. Of course, 2.365 is greater than 2.059. So in this case, we accept null. Accept null, which is h naught, and reject ha, the alternative. The last step is to draw the conclusion. Having seen that we accepted null and reject the alternative hypothesis, so we look at what the null hypothesis states. The null hypothesis states that the pH of the beer produced by the brewery is 3.6. So the question says, should the process of brewing continue or an adjustment of the machinery be ordered at 5% level of significance? Since we accepted null, which states that the pH of the beer produced by the brewery is 3.6, we then conclude that the process of brewing should continue and there will be no need for adjustment of machinery. So we'll report that now. So we're basically giving an answer to this question. Please look forward to subsequent videos and don't forget to subscribe to my channel, turn on the notification bell, like this video, share out and leave your comment. Thank you so much for watching. Bye.